Okay, today we are continuing with 1.8b composite functions. Just say composite. And today all we are just learning about is f of g and g of g and g of f. So as we know from yesterday, if we have f of g of x, we are just putting whatever is g of x into f of x. Let's give f of x a function. Let's say f of x equals x plus 2, and let's say g of x equals 3x squared. We'll just say 3x squared. However, today we're also going to show you a different form. F of g of x could also be written as f of g. So just likewise, if you were to have g of f of x, let's erase that, g of f of x, that would be written as g of f. And then finally, what if you have g of x? Well, that is just written g of g. Let's go and see what some of this could look like. So if we have f of g of x, that means we take 3x squared and we put it where x is. So this is 3x squared plus 2. G of f of x, well, we put x plus 2 wherever there's an x squared. This is actually 3 times x plus 2, and then we would square it plus 2. Of course, we would have to FOIL this out and simplify. Lastly, g of g, well, that would just take 3, and we take 3x squared again, and then that is squared. So this actually becomes 3 times 9x to the 4th, which is 27th x to the 4th for g of g. So let's think about domain again when it comes to variables with exponents that are not even integers. So let's say we have a x to the let's say 5/3 or 5/4. Let's say x to the 5/4. This is the same thing as saying 5 x to the 5th and then the 4th root of that. Well, if we have a 4th root, we know that we cannot have anything that is a negative, right? So our domain could equal 0 and go on to, it could equal 0, but then it could go on to positive infinity. And that would be our domain here for an uneven with a weird, not weird, but fractional exponent. Next, let's talk about how would we evaluate these functions if we were just given a graph. So let's draw 2 graphs here. Let's draw the first graph. This one we'll call f of x, and the second one we'll call g of x. And let's say the first graph looks like, I'll put in some points here. Let's say the first one's a parabola. And it looks like this. So it's important to know the points here. So this one I'm going to be careful with because the points really do matter. I mean, the points always matter, but most of the time it's kind of a but this time the points are important. So I'm going to connect these here just so you can see where the points are and what that means. Let's draw g of x. Let's say g of x is a negative exponent, or a line that looks kind of like this. Like so. I'm just going to draw some points here just to give us some idea what we are working with. Okay, so let's say we want to solve for a composite just using our graph. Let's go here. What if our question says we want f plus g of x? What does that mean? F plus g of x, but specifically f plus g of x, but in terms of a number, they give us a number value. So let's say the number value is 2. Well, we just got to go over 2 on our x's and find out what that means in terms of our y. So 2 for f of x is we go over 2. That is actually 1, 2, 3 for our y's. So that is actually 3 plus g. G, when you go over 2, there's 1, 2. So it's 1, 2, 3. That is 1, 2, 3. That is also 3. So our answer there is actually 6. Okay. Let's try another one. So let's say we want f divided by g of, let's say, 3. So then we're just going to go over 3 on our x and go up and see what that means. Over 3 for f is 1, 2, 3. Up, that goes 1, 2, 3, 4, 5, 6. It is 6 up for our f of x. So on top here, this is 6. On our g, we go over 3, 1, 2, 3. We go up 1, 2. That is 6 divided by 2. Our answer is 3. Finally, what if they wanted, let's say, f of g in terms of 3? Okay. So what we need to do when we find f of g, what we're doing is we're taking our g value and putting that into our f. So first we need to find out what g is at 3. Well, at 3, g of x is 2. So then we're going to take that 2 and we're going to go over to our graph and then find out what f of x is at 2. So then we go over 2 and that equals 3. So our f of g of 3 is 3. So then let's do that backwards. What if we have g of f of 3? Well, now we got to start at f of x. F of x at 3 equals, let's see here, 1, 2, 3, 4, 5, 6. F of x at 3 equals 6 here. So this is 6. So then if we go over 6 to g of x, it's 1, 2, 3, 4, 5, 6. It's actually negative 1 down here. Negative 1 down here. So f of g of f of 3 is negative 1. F of g of 3 is 3. And that is all for 1.8b.